Yes.
Okay, sir. Uh, so now I would like to introduce Dr. S.S. Pusatkar, sir. He has completed B in Civil Engineering from VNIT Nagpur, ME in Geotechnical Engineering from College of Engineering, Pune, and PhD from IIT Roorkee. He is working as a HOD and Teen Planning and Administration in Government College of Engineering, Nagpur, having more than 31 years of teaching as well as industrial experience. Presently, one doctoral candidate, over 25 masters, and 32 BTech candidates have completed their project under his supervision. He is a member of 11 professional organizations such as IGS, ISTE, IRC, ICA, etc. He published more than 98 papers in national and international journal as well as in conferences. Also, 5 book chapters were published. He has completed 2 R&D sponsored sponsored by AICT project. His one patent has filed, and also sir is a reviewer of geotechnical and geological engineering, Springer Nature. As an organizing committee member for various workshop training program, several events were organized by Sir. Sir has handled many additional responsibility like BOS member, member of academic board, dean academics, chairman of IGS Amravati chapter, and chief person at various conferences. With this brief introduction, I request to Dr. S.S. Pusatkar sir to deliver the lecture. Thank you, sir.
Thank you, sir. Uh, Today I am is the in the dual role as a coordinator as well as today's speaker because of some medical reason of Professor Prashant Nagrale. Everyone knows this pandemic is going at Mumbai, and therefore he is quarantined and he could not able to deliver the lecture, but his health is good. So the topic was aspect of sustainable pavement constructions. I had changed to my field, aspect of sustainable geotechnology for pavement construction. So in this sustainable geotechnology for pavement construction, we are going to see the material which is different materials and methods used for the improvement of the subgrade and some aspect of pavement as well as the slope protection with the natural resources. So with this brief introduction about this, I will look out to the my presentations. So for transportation engineering, the ASTU 2009 has defined this sustainability, what the sustainability should refers to the transportation engineering, and it states that transportation's mission is no longer about just moving the people and goods, it's much broader. Transportation fundamentally allows us to achieve economic, social, and environmental sustainabilities. So, all the three principles of sustainability are included in the transportation, and this transportation supports and enhances our quality of life. As state transportation professionals, we need to model the way towards achieving a sustainable future. Sustainable transportation requires innovative approaches and partnership like never before. So this transportation engineering is not sustainable transportation engineering is not only the uh, field of field engineers or the field of only the researchers, but it is conglomerate of all the persons who are involved in this process, and hence the responsibility resolves to everyone. Already we had discussed some of these points, but I just reiterated because on topic on sustainability, everyone knows why we are going for this sustainability, because we know the current situation, there is a global warming, average sea level is increasing, snow cover is reducing, global energy consumption is very increased to 22%, fossil fuel burning is also 25%, there is a threat of air pollution and greenhouse because that is also increased to 30%. Landfill cover is reducing, and reduce the amount of water infiltrating into the ground. And hence, therefore, yesterday we had that one lecture on rainwater harvesting, and I will discuss only one slide on this issue, how we can make our payments so that the recharging of the ground will be continue. So sustainability definition is already defined by earlier authors, earlier presenters, but I am defining the sustainability with the Brundtland Commission report, which held in 1987, that sustainable development is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So it's our prime responsibility of today's administrators or the peoples are living on the earth, that they should keep this earth as it is, so that our future generation will also able to take the benefit of the natural resources which are exist on the earth. And therefore, these three pillar of the sustainability, we say, as a economical, environmental, and social, it combines together, results into the sustainability. There will be combination of two either also, but entirely if I look into all these three aspects, it results into the sustainability. Now, in context of this payment, how I should make a sustainable way? So it can be achieved the engineering goals for which it was constructed. That means what are the road or the railway pavements we are constructing, and during that construction we have to keep the focus on that engineering aspect, but then we have to preserve and restore the surrounding ecosystem. That is main thrust which we should keep on sustainability, that whatever the way we are making the roads to any area, and we have to preserve this ecosystem. And the best example is the construction of national highway from Nagpur to Jabalpur. They had preserved this ecosystem very soundly by providing many underpasses for the animals which are there living in this particular area. It's also used financial, human, and environmental resources economically. That's all. Definitely, engineers is the first fundamental prime, is that you should go economical design, construction, and also maintenance should be kept minimum. Meet the basic human needs such as health, safety, equity, employment, comfort, and happiness. By the pro of payment, we can able to provide this human needs. Definitely, because if there is no road, no man can reach to the hospital, no man can reach to the office, nowhere even can move. And hence, if you keep this road network, which is more than lakhs of kilometers in the on the earth's surface, if you are keeping this in a green way, definitely we will be able to preserve this earth in the sustainable way. Now, there are three parameters basically, as I discussed earlier: environmental component, social component, and economic components of the sustainability. With respect to the payments, basically it regards to the energy consumption by the materials, by producing it during production, during construction, or whatever. So the energy component, it is a major rules, because how much energy is required for preparing that particular material, or how much carbon dioxide they are evolving during the preparation, that also we have to take into account. The greenhouse gas emissions, noise, air quality, stormwater treatment, all that comes under this environmental aspect. Whether if you look at the social aspect, it basically results to the safety, smoothness, vehicle operation cost, again the GSB emission through this vehicle, access, mobility, and aesthetics. So these are the various points which you covered under the social component for the payment. And the last point is economics. Definitely, we should achieve economy through construction, maintenance, and rehabilitation cost, and vehicle operating cost, crash cost also. So all these are the various points which refers to the sustainability in the payment. But we will look out only two aspects of the energy consumptions and the constructions in the construction of these payments. The figure which is shown here is two different highways. One is going through barren land, other is going through a very greenery area, and definitely everyone prefers to have the roads in this fashion. And if you are able to provide the greenery around the roads, your journey will be very comfortable. Also, we will save this earth from disasters. Now, why the sustainability requirement measure it plays a major roles in the pavement. This graph which showing you the is by Wenger, who has written in Materials in the Economy, that it shows how much different variety of the materials are used in the last complete 100 years, in the last 1 century. And out of all these materials, if you see, the crushed stone, sand and the gravel plays a major roles in the construction industry. Everywhere we are excavating the material and use it for various type of constructions. The most of the roads which we are constructing are definitely on the earth itself, and therefore there is excavation, there is construction of embankment. So large amount of crushed stone, sand and gravels are utilized during the construction of these highways or any type of roads. And hence our most focus or prime focus should be on this construction material which is used for the construction of pavements. Everyone knows about these two type of pavements. We have the rigid pavements and the flexible pavements, but all these pavements will be definitely resting on the subgrade, that is the existing soil. So sometimes we need to improve the subgrade also, so that I will able to carry the load which is coming from the pavement or which is coming from the concerned road. And then the rest of the portion which is above the subgrade will be sub-base course, base course and concrete pavement. That is, the figure is reverse way, it is wrong. Okay, that title is wrong, sorry. And for flexible pavement we have the sub-base, base course and surface course, right? So if you look at the flexible pavement, most of the material required is earth material, only the bituminous part is there, and even rigid pavement also, only the top pavement is of the concrete pavement. That block is concrete pavement. So there are a lot of research and the work is going on to reduce the material utilization in the construction of the roads. So we will look out some of the area wherein we can able to save the material from the construction of these highways. And this type of various layers we have, say, we may have embankment or the natural ground, then we have subgrade, then GSB and then WMM, right? We can construct this sub-base also and compact it, and then we keep our next layers on it. So how do recycled material fit in this requirement of subgrade as well as sub-base? Why we need to use this recycled material? Definitely, if I use recycled material, I will go the way of sustainable approach for the construction of pavement. So I can avoid energy and emission associated with the mining and processing construction materials. If I am using the virgin materials which is excavated from the borough area, definitely I will dig out the hills, brought those materials and dump it for construction. So we consume the energy for excavation, construction, and so that lot of energy which is used will be saved if I am using the recycled materials. So energy has already been expended in the first life of the recycled materials. So that energy I can save if I am using recycled materials. It can avoid the use of natural resources such as sand, gravel, limestone, oil. It also increases the life, not an infrastructure landfill, but a comparable or better, longer lasting infrastructures. Because once suppose now the bituminous roads are existing and we are constructing the concrete pavements. So entire material is excavated and then started again placing your sub-base, base course and then your concrete pavements. The most of material which is excavated during the excavation of that existing road, nowadays the people are recycling that material and using it in various ways. And the road which will be making of that recycled materials definitely will increase the service life of the material also. And the next is the capital and life cycle cost can be the lower. So we can restore the third component of sustainability, that economics. So as we require two type of materials, one is the coarse grained materials, other is fine grained materials, right? So we will look out the different materials which we can use as a recycled material for the construction of the sustainable pavement. Recycled concrete aggregate, a lot of breaking of buildings is going on, the concrete roads are broken also, so that material can be separated and use that aggregate, recycle that aggregate, and we can use it. Similarly, asphalt concrete, if it is removed, you can recycle the asphalt concrete, separate the aggregate particles, and those particles can also be reused. Similarly, foundry sand from iron casting, that can also be used in construction. Bottom ash from the coal combustion. During coal combustion, as we know, everyone knows about the fly ash. The fly ash which is used in the cement production or in the construction of embankment also. But during the emission of this fly ash from the thermal power station, the another ash which is dropped at the lower level, that we call as a bottom ash. Nowadays, they are separating fly ash and bottom ash separately. The bottom ash has uh, the the benefit that it has the size near about equal to the sand, and its specific gravity is low. So we can compact that bottom ash in the embankment with the lighter load on your embankment. Crushed and mixed glasses. The glass material which is broken we throw away, and it is thrown in the garbage. So if I reutilize this broken glass pieces, I can use as a recycled material for the construction of pavements. Wood chips, shingle shreds, that is the tire shreds and tire shreds and shingle shreds. These are also, a lot of research has been done on this aspect, how we can utilize the tire shreds during the improvement of the embankment construction or the subbase construction. Shredded plastic and crushed thermostat plastic. This plastic utilization is also uh, the work has been carried out by many authors, and they are in practice also, but it is very limited form. And the last is polystyrene foams, which can be utilized as a recycled materials as a coarse grained materials. So these are the few slides which shows you the recycled concrete aggregate from building demolition. We can note down the brick fragments, reddish color or high fraction of finer particles, more sensitive to the water softening. So this, the disadvantage of that is it will become softened, but we can separate it and we can utilize the proper recycled concrete aggregate. Recycled concrete aggregate may be obtained also from the pavement, so that will be clean and angular, stiff material compared to the RCA, that is recycled concrete aggregate from the building demolition. So residual cement bind particles together when it is moistened. Okay. This is what I have talked about, the bottom ash. It's look like a sand but has a lower specific gravity, and the particles more prone to crushing, can have contaminants because it is a mixture coming from the coal ash or thermal power station, so it may have contaminants. So we may need to segregate those contaminants, but it can be very widely useful as the construction material for the subgrade and the subbase. Another is from slags from the factories. The grey iron slags looks like a pea gravel. This slag is porous, like tough because it was quenched in water, so more prone to particle crushing than natural aggregates. So you have to take proper precautions, and hence a lot of research is going on the properties of these materials which you are reusing it, because it has this particular material has gone through one cycle of their life, and we are and they are under stress condition during utilization, and now we are separating them from the existing structure, releasing from the stress, and again we will be cleaning it and then use for the next construction of the pavements. Okay. The other material is the residual asphalt coated materials. As if you when I'm removing the bituminous road, definitely we'll get this uh, coarse aggregates which can be used. The stick from asphalt brings up to strength and stiffness, but it has also a creep problem. So but it runs more rapidly than the conventional aggregate. So we should find out the proper place for the utilization of this recycled aggregate in the construction of pavement. So this RAP and some RCA can blend probably from milling of HMA overlay over concrete pavements. Okay. This is another about the tire. Shredded tier of shingles contaminated with the wood chips, lightweight but compressible, and hence they are also creeps and temperature sensitive. So you can use the pieces of your tire in the construction, or you can shred it into the small particles, and then you can use it that shredded and the tire grips. Also, you can use the sand which is obtained from the foundry, grey iron foundry with the low bentonite contents. They are black color from sea coal using the reducing agents. So the more moisture sensitive when higher bentonite contents, and hence you have to take a proper precaution again utilizing these all waste materials. They can be used for lightweight fill such as tire, foams, crushed thermostat, embankments, basins of course for pavements, drainage media, structural fill for slabs and retaining walls. Similarly, we have some of the finer materials or fine grained materials which can also be utilized as the recycled materials, such as I said the fly ash. It has some fly ash are self-cementing, some fly ash are non-cementing. So self-cementing fly ash and non-cementing fly ash should be separated and utilized either in the construction of pavement or the production of your cement. The fuel gas desulfurization sludges, that is called FGD, foundry slag from iron casting, which contain higher bentonite material, paper mill residuals as a sludges, dredge spoils. These can be used as a fine grade recycled materials during construction of pavements. It shows this some soft paper sludge or the ash contents with their microstructure of the ash is also shown there. You can use these FGD gypsums which I discussed earlier. It may be used, it addresses the problem of plasticity, but the problem with the entry we use as agriculture impediment or for drywall production. So mostly it is used for the drywall construction. The FGD filter cake can be blended with the cementitious fly ash, and you can make aggregate using those material also. So we can use this recycled fine aggregate materials that fill in the application where lower strength and higher compressibility are acceptable. High strength fill when blended with the other materials, and cementing and stabilization of the soils. That we can use this recycled material, fine grade recycled materials in this variety of material. Now, while understanding these various recycled materials, we are using it in the construction of pavements. Also, wherever we have existing ground, it may be a weak soil which cannot bear the load of pavements, and therefore we need the improvements of those existing soil. And definitely there are n number of methods which are available for present improvement of the soil. So we can use, if we want to be a sustainable subgrade method, a subgrade improvement method, that is soil improvement methods, definitely my material should be not using chemicals or hazardous additives for improvement of the soil. It should, if I use the waste material, definitely it goes a green way, or I can use some natural or biodegradable material for improvement of the soil, or the new recent research which is going on throughout the world of utilization of microbials in the soil improvements. So I will give some focus on this and some focus on bioengineering aspect how this existing or the grass, existing trees or the grass will be holding your soil mass together, and how we can utilize this for the slope protection or from erosions and so that the aspect we will look after. So the majorly I will cover these three aspects about natural or biodegradable materials, microbial soil improvement and bioengineering. Now in our the ancient people also had worked in this soil improvement, but that time they had used 100% green methods to improve the soil. The Professor A.S. Nene from VNIT Nagpur, he worked on this soil improvement or the soil material used in the ancient days, as is mentioned in the Rigveda or so, and he had published this book on the ancient soil improvement. So there he mentioned the marshy land was stabilized by gods using sand. That was the Kapi Smita in 6.7 he says. But that means that soil can be stabilized, marshy land can be stabilized not by the god, by using sand. Automatically when they mix it with the that marshy land, sand mixed with this marshy land, over the period of time it getting improved with the consolidation, the overburden which is taking place on it, and it is getting converted into the stable land. They also mention that if your water ground is waterlogged, then that time what they were doing, the water should be drained out by digging drains parallel to the northeast and refilling the trenches by brickbats and stone so that the excess water drains out. Now whether it is northeast, southwest, that depend upon how your natural slope of your ground is. But to the waterlogging problem which we are facing in the many of the area where higher irrigation is there, right, we are using different methods, but the natural process they had given us that you can refill it with the brick bats and stone similar to that. The Professor Nene also talked about his ancient natural plasticizers. We are using now various chemicals to use as a plasticizer, and in the ancient literature, it has been mentioned that the extract of herbs, fruits, and the tree barks can be utilized as a natural plasticizer, such as Avla, Triphala, that is Avla, Hirda, Behada, which is shown in the as one number, wood apples, which is called kavat in Marathi. Number two, the holy tree fruit, that is we call the bale fruit. Then barks khadir, it is the chick from that khadir tree, and Arjun tree also. Now, the to find out the suitability of all these natural materials for the construction of the soil improvement, the lot of work has been carried out by Professor Nene also, and few works under my guidance, some students has carried out on utilization of this material for soil improvements. So few of them I may discuss. Then that time also the natural fibers were also utilized, such as cotton, coir, wool, jute, and nowadays we are using coir and jute as a ground improvement textile material for at different levels, right? Similarly, there were another natural polymers. They were say is a cow dung, jaggery, that is good, coconut water, that was also a good plasticized polymers, the eggs, green algae, and burned coconut shells. Those were used as natural polymers during the, and all these are sustainable materials. So basically, because that was chemistry was not evolved that to that extent that it can change the property of materials, and hence they try to utilize initially the peoples try to utilize only the existing material on the earth, and we are using. So this is the work which is presented or work carried out by my students Palash Domre. He had used that bell fruit powder to check out the change in the property of the black cotton soils. And to our surprise, we found even if I use the 1% of this powder in the black cotton soils, its unconfined compressive strength was increased by near about double, right? Depending upon how many days I had cured that particular uh, mixture. Okay, so this graph also indicate that how your unconfined compressive strength is increased from 128.9 to 419, right? For this is only for the 1% of uh, this bale fruit powder. So definitely it is natural materials, we can use it, and this bonding, of course the further work is necessary whether this is durable, whether this binding which has been developed will be remains forever during the life of that particular materials. These are the CBR values which shows the improvement from untreated soil to 4.89 to the maximum is 11% in unsoaked condition. In soaked condition from 1.26 to even 2.77, so around 2.5 times uh, increase in the CBR also observed by using this bale fruit in the black cotton soil. So this is a good natural material which you can utilize. The jute textile in pavement construction everyone knows, therefore I had not much elaborate on that. That we can use in the pavement construction as well as also slope stabilization product. It is just as your geotextile materials. And a lot of research has been carried out on jute also to use it in the different forms, in the construction of the pavement. So this is a very good sustainable approach, I can say, for construction and the improvement of the soil as well as protection. Similarly, the coir fibers, basically jute work is going on mostly on the northern sides, whereas this coir fiber works mostly going on the south side. And they also uh, turned these coir fibers into variety of mats, geocell or geotextiles, and they are utilizing it for the improvement of the soil. And this one figure which shows that bearing pressure on a footing, how it is increasing with different type of the coir fibers or coir fabrics they had used. One as a mat, other as a geocell. So definitely, so of course, some treatment is required for this to reduce the degradation of these natural materials. Otherwise, we can definitely use the natural fibers for the construction of your pavement as well as improvement of the soil. This is another fibers which are used as a natural fiber is banana fibers. Now the banana fibers, in Maharashtra we know that in Bhusawal and Jalgaon regions, lot of people are growing these bananas, and there are some industry also in that area which converts the stem fibers into the fiber mat and banana cloth also, and as well as this individual fibers also can be utilized. Okay, so this also shows how this is improving the CBR value by using these banana fibers. One of my PhD student is working on this utilization of banana fibers on soil improvements. So I will not put their result here because their research works. Just I am mentioning that they are working on that issues. Then another, the burning topics today is this microbial soil improvement. That the, the soil improvement carried out with the help of bacteria is called as microbial soil improvement. And in the last 5 years, lot of work has been done on this area. Of course, the the actual field practicing is yet to be demonstrated, and it will take some times, but it will be evolving as a good material, this bacteria as a good material for soil improvement. These bacteria are also used for the concrete also. There are bacterial concretes are available, self-treating concrete also are available, So these bacteria which are around us can be utilized better way if you treat it properly and utilize it properly. So biology in the evaluation of geotechnical engineering is emergence of biosoils as a sub-discipline. Now we have geotechnical engineering, foundation engineering, geoenvironmental engineering. This another biosoils will also come up as a separate discipline in near future. The potential of biology to modify engineering property of the soils by length scale of biological process, methods of applications, potential improvements to the engineering properties with this biochemical process. So this treating bacteria with soils involves lot of actions, reaction among the bacteria and the materials, because your soil contains all type of minerals which are available there. So we have to see how this will react with different type of materials, and also in soil lakhs of bacteria are available. So we have to introduce such bacteria which will improve the soil properties. Not all the bacteria will improve your soil properties. So this slides will indicate you that how, if I treat the soil with the bacteria, the mechanical properties will be how much it is increased or reduced. Permeability is reduced, stiffness is increased, compressibility is reduced, shear strength is increased, and volumetric response is also increase or decrease depending upon their bacterial performance. But major three properties which we required, the strength, compressibility and permeability, these are definitely improved if I use this bacteria in treatment to the soil masses. So we can apply in the field for soil competitive, pore fluid composition, biostimulation, bioaugmentation, spatial uniformity, or permeance. So there are many ways you can use in the field applications. That is also just on some model stage, model study stage, not yet applied in the field directly. So first we understand these microorganisms are found in almost every habitat present in our nature as discussed. Microorganisms are vital to humans and environment. They are present in soil influence of the and influence the soil structures. And microorganism can be grown easily for multiple purposes. What is the function of these microorganisms which are used for soil improvements? Microbes play important roles in soil. They participate in earth element cycles such as nitrogen and carbon cycles. The function of microorganisms and are decomposition of organic matter, cycling of minerals, plant, uptake of minerals, etc. Cementation of soil particles through release of glues. This is the last point, is most important from the soil improvement factor, that whatever the uh, glues are released by this bacteria, how we can use that do for cementing the soil particle and improving your soil properties. There are many types of bacteria, but I had class takes into only the 4 type of bacteria which are required for improvements, for required for soil improvement. One is photosynthetic organisms, that is cyanobacteria and algae. The sulfate reducing bacteria that are responsible for discriminate reduction of sulfates. Organism utilization of organic sites. Organism that involves the nitrogen cycles, either amodification, amino acid, nitrate reduction, hydrolysis of area. Right. There are 4 different methods which can be utilized for uh, making the change in the soil properties, either by bioclogging, biocementation, or the MICP, that is called microbial induced calcite precipitation, or by biogroutings. So we'll see in short all these 4 methods. The first is bioclogging, means we know the original soils has lot of voids, and if I able to build up the bacterial growth and cemented these particles together, which has which is filled in the voids. So definitely the particles are getting attached to each other, and the voids also will be reduced, so permeability will be decreased. This bioclogging is the production of the pore filling materials through microbial means, so that the porosity and hydraulic conductivity of the soil can be reduced. So aims at making soil more impermeable So bioglogging can also be used as a seal leaking construction for peat, landfill or the dike. It has no direct relevance to the pavement, but I had, because I am describing microbials in details, so I take all this area where it can be utilized. The production of bacterial X polymers in situ can be used for ground improvements. If I am using the particular bacteria, X polysaccharides producing bacteria also improves the ground by reducing the permeability. This concept is also used in earthquake liquefaction mitigation, long-term stabilization of the soils. Application of ammonium solution decreases the hydraulic conductivity of the soils. So this bioclogging helps tremendously for soil improvement. Then the cementation, biocementation. That means we are integrating the particles with each other, attaching the particles with each other with the help of this bacteria. So this biocementation is generation of particle binding materials through microbial process in situ so that the shear strength of the soil can be increased. It is the formation of the soil particle binding materials with the aid of microbes and their additives. So the shear strength which is meant for bearing the load is definitely increased by using proper bacteria with the proper treatment for this strength will be shown improvement. The binding of soil particles with the sulfides of metals produced by sulfate, the sulfate reducing bacteria is useful for biocementation. Binding of soil particles with the carbonates of metals producing due to the hydrolysis of area, this is also used for biocementation. Binding of particles can be performed with the ferrous and ferric salts and by hydroxides produced due to the activity of iron reducing bacteria. So these three bacteria, that is sulfate reducing bacteria, hydrolysis of area, the bacteria which use those as a growth, and iron reducing bacteria, these can helps in developing the cementation in the soil particles. Then this broad area is microbial induced calcite precipitation, biobinding, the formation of particle binding cellular chains. By oxidation, reduction, dissolution and precipitation of organic substance can only form stable and strong binding of soil particles. So these four phenomena has to be takes place in soil with the help of this bacteria. Then we can improve the soil definitely by using this bacteria. So bacteria have typical size from 0.5 to 3 micron. So mainly it is used for sandy soils. So because the sandy soils is a porous and your bacteria will be bacterial liquid or growth will be penetrated into this sand easily, and we can have a uniform mixture of the sand and this one. So the creation of calcium carbonate cement occurs as a consequence of bacterial metabolic activity that raises the pH of the proximal environment. So microbiologically induced calcite precipitation occurs according to the reactions, these reactions which are there. So a lot of chemistry is also required for understanding this MICP process. Then you can go for biogroutings. We know the cement grouting, chemical grouting, everything are used for improving the soil properties. But even if I use the cement grouting or the chemical grouting, they have the limitations of the we are puncturing the chemicals into the ground, and by over the period of time, sometimes with the leaching maybe takes place, and those chemicals which are used in groutings will be contaminating your ground as well as groundwaters, and hence definitely they are not safe. So if I am using this bacteria as a grouting materials, it will seal the cracks, it will make the soil impermeable and improve your properties. So biogrouting decreases permeability up to 98%, and definitely when it's sealing the cracks, it will binding the particles, so it will increase the strength up to 12 MPa for that particular type of sand which has been tested. It includes injection of the specific group of microorganism into the soil mass which connects the existing sand grains and therefore increase the strength of the materials. In soil improvement, the bacteria which is used majorly is Bacillus pasteurio or the Sporosalina pasteurio. So the Pasheri group bacteria is mostly useful in MICP because of their ability to produce high amount of precipitates within the short period of time due to their high urease activity. So this is most of the research work has been carried out this, but the many people are using different type of bacteria. In one of my student is also working on this microbial soil improvement. She is using about 4 different bacteria, and the work is going on, is on the verge of completions. I am just putting you some of the bacteria which has been referred in the literature by various authors, and they show how the soil properties has been improved. That Sporosaccharina pasture, the UC has increased up to 12 MPa because it's improved the strength with the formation of calcium carbonate. Then again, the another author has used Sporosium pasture. The stiffness increased significantly only after 1 day. When I use a ferrous or ferric salt based biogrout, the permeability is reduced to a great extent. And soon Lee and all others, they use MICP treatment. The shear strength and permeability shows improvement. These are I shown only very little for. A lot of material is available on this microbial soil improvement. This is the work. These are basically the review work done by the Rahman et al. And she produced in 2020. Shows so many author had worked on the soil to understand how this bacteria improves the unconfined compressive strength of the soil. So we can see, depending upon the presence of calcium carbonate due to the bacterial activity in the soil, how your unconfined compressive strength is increasing. It shows improvement up to say 15 MPa. So 15 MPa of value for soil is very great values. The same author has shown is the tensile strength of the soil. Everyone knows the soil is weak in compression as well as tension. It has good shear strength properties. But in some cases we require some tensile strength of the soil also, and this MICP treatment shows that splitting tensile strength is also increased to a great extent. Of course, that depends upon how much calcium carbonate content develop in that soil. These are the results of the triaxial test, where it shows the deviator stress increase with the different type of bacteria which they had used. Again, it is reported by Rahman et al. Now, the same author has worked on the sustainability aspect of this microbial induced calcite precipitation. So, he is a state of art review of microbial induced calcite precipitation and its sustainability in engineering applications. And since he has connect his research work or the review work with the sustainability, I had taken only the sustainability part and some of the results to show you the improvement in the soil property because of use of these microbes. For understanding the sustainability analysis, he had taken 3 different model. So, in example, the configuration of CBP, that is, so the pavement containing only granular base course, here only the granular base course is used, and he had does this analysis only for the paver block road. Okay, so you can implement the same system for other type of road also. But definitely, if I using for different roads, I may get different results on sustainability. In the second case, he had taken sub base, base course, and then I have a paver block. And the third case, he had stabilized the sub base course, and the paver blocks. Right. So we will see how these 3 different type of matter is the sustainability analysis. After doing exhaustive work, he had presented this life cycle of conventional concrete blocks and MICP treated concrete bricks and the associated economics and environmental cost of the process stage and in the final stage. So this is case 1 I am presenting only for the the base course and the paver blocks. Then one is using the granular base and subbase course. The treatment is given MICP, right? So for this case, what he has shown when they had using this base course, excuse me, yes, hello sir, नमस्कार, हाँ सर नमस्कार, हो सर, चालेल चालेल, नो प्रॉब्लेम सर, ओके, हाँ सर, मग आता माझं लेक्चर सुरू आहे. Sorry for interruption. This call from the next speaker. So, what is trying to show you here that what is the carbon dioxide emission, the energy consumptions by the different materials when I am using the MIC treated materials and when I am using the cement based materials. So, in the first figure you see here, cement is there. It shows how much energy it consumes, how much carbon dioxide it exhales, and what is its cost. Then microbial treatment material, how it is used, this energy, carbon dioxide emission as well as the cost, and the aggregate is the same materials required for both. So he has taken into account 1 kilometer road, and based upon that 1 kilometer road length, he has of course for the microscopic treatment analysis, cost analysis, the cost as regards today is not available, but he had assumed some values based upon the reaction treatment which requires and the periods which is required. So after manufacturing, if you go to the manufacturing plant and prepare your conventional concrete and MICP treated concrete, now he is talking about only MICP concrete and conventional concretes. So when I am using this MICP treated concrete as the as a material for the road construction, it shows the reduction in the energy consumptions from 2477 to 2110. The carbon dioxide has been reduced from 450 kg per cubic meter to 365 kg per cubic meter, and the cost is also reduced. So if I use this microbially treated concrete in the pavement of your roads, we will be definitely go for sustainable way for the construction of the concrete pavement. What has been illustrated by this paper, he has demonstrated the same study here also in the different manners. So environmental cost, economical cost for MICP treated soil and conventional concrete pavers. So what it shows here that the MICP treated paver block will have 19% environmental benefit, whereas as per economy it will be 25% cheaper than your conventional cement concrete paver block. So this definitely shows the way for a sustainable way for using this MICP treated blocks for the construction. Now he had studied for the treating the stabilized subbase and cement treated stabilization, and the pavers are common for 1 kilometer. So the case B, what he has taken, MICP treated stabilized subbase and the paver and the cement treated stabilization basis. Okay, but he observed in this case that the environmental loss by using MICP treated stabilized subbase and the pavers is 339%. So here is showing this is not sustainable way. And for economy also it is there will be economical loss if I using MICP to the extent of 166%. So as I said, case to case basis it may change, and hence you have to verify before using this treatment whether it is sustainable and economical or not. The third case when he has done that MICT treated subgrade stabilization and the paver with cement treated stabilization and paver with cement treated stabilization and the paver. So he observed in that the both losses are reduced to the great extent. Okay, environmental loss from 339 to reduced to 19%, and economical loss from 166 to has been reduced to 9%. So he had changed the process, they uh, the both economical as well as environmental impact showing their effect. So a lot of work is required in this area so that it will go more sustainable way. And what is putting in the next slide will show you that in the sustainability analysis, two of the three MICT treatment scenarios cost more and had larger CO2 footprint, and thus may not be economically viable and environmentally sustainable technology, at least at the current time. That is the main point. You have to understand this is not economical at that particular point of time, but if I change the technology, change the methodology, definitely MICP will be a more sustainable approach than any other approach. So alternative sources of nutrients might lower the cost and environmental footprint. A number of alternative solutions are currently being explored. As I said, this is just the more glowing area for the research. With further research, this technology can potentially be cost effective as well as environmentally friendly, particularly since it uses natural process. The use of biological and other waste effluents in the process will further enhance the environmental benefits in terms of reducing CO2 and energy footprints. And therefore, it emphasizes that MICP treatment will be most sustainable approach for improvement of your soil or for construction of your pavement. That will show in the next 10 years, definitely it will take that shape. So that was improvement was over. Now I go to the another approach for sustainable way by providing a porous pavement or providing a recharge bed for rainwater harvesting. As I said, this is the permeable parking lots construction done at one particular site that presented that this parking slot, as it is used for the recharge bed concept, the same concept can be used for the pavement. If you are constructing the porous pavement, a lot of work is going on porous pavement also, and you can have the storage tank below. So the surface water which is there will be drop into the storage, and we can save the flooding of the most of the area now which we are seeing in the major city like Mumbai, Chennai, or any even international also, they are getting flooded because we have trapped all the natural sources or natural pathway for the flow of water, and everywhere we have done cementing or bituminous carpeting. There is no way to seepage or the water to be groundwater to be recharged, and hence this particular concept is also a most sustainable approach for recharging our groundwater. So you can construct the porous asphalt pavement or the concrete pavement and recharge the groundwaters. This is one more concept used in sustainability of the pavement. Now, when we are constructing the embankment, the embankment has to be protected from erosion. Nowadays, there are many methods available for protecting these slopes also. Say maybe by using geonets or shotcrete methods, right? Or by some facial wall, retaining walls, and so and so. But if I want to go a sustainable way, definitely I should use this bioengineering concept to control this erosion. Okay. So when naturally, if there are the trees which are grown on the ground surface, they will serve both the purpose. They will control the environment, and also they will reinforce the soil mass, the loose soil mass which is above the bedrock, right? So that natural reinforcement of the soil protect the soil from its erosion. Nowadays, the lot of trees are cut, they are uprooted from the ground, and we are making very soil very vulnerable, and the erosion of the soil is continuously going on during the floods during the floods. Lot of soil is moving into the sea. This is major thrust, uh, the major problem for us, because if the fertile soil is moving, then there will be problem for your food production. So there are many ways which we can use or protect these hills by providing the brush layering and brush packaging. So you can put these, all material is natural materials. They put this uh, 3 to 8 inch thick and 6 to 8 feet long sticks, making as steps to protect the movement of your soil, fine soil. This will be protecting, and over by year it will be uh, filled up that area, and we can protect the slopes for erosion. Another is the typical slope failure along the hillside in Himachal Pradesh that has been protected by planting that undertaken by the PWD Himachal Pradesh, and it shows that this bottom uh, photo shows you that the stabilized slope along the hillside after application of this bioengineering technique in Himachal Pradesh. So they had implemented this process to protect the hills also. Another way is by cordon constructions. So you can construct the heap of natural materials, and then it is filled with the soil, and naturally the after few months or the years they will be covered by the grass, and the soil mass will be protected. So this is soil bioengineering site photograph at the bottom, which shows you how it can be protect that soil mass. So I come to the end of my lectures. So what concluding remarks I can put it as sustainability is the need of the hour. The pavement construction is a process which consumes large amount of earth materials, and hence we need to use waste materials which will be reused in the pavement construction, and that will save a lot of natural materials, naturally available fibers, polymers to be used for soil improvement. Microbial soil improvement has a great potential in improving soil in green engineering, and definitely next 10 or 20 years this field will be grow up just like as geosynthetic has been improved last 30 years. Porous pavement development is necessary to recharge the groundwater. That is just a beginning. The thought is coming up now for uh, preparing this porous pavements, and how it is implemented, let us see. And the last one is bioengineering, which is used for erosion and erosion control of the slopes and the hills, is to be potentially used. And this will save us both way. It will protect the slope as well as it will give you the greenery surrounding you. So with this, I conclude. Thank you very much for patience listening to me. Now, if you have any questions, we can take those questions.
Thank you, sir. If participant have any question, please put in chat box.
Yes, Dr. Saab, it was a very nice session, and it was very new topic that bacteria in whatever soil in MIP method you have given MICP. But my general question being researchers, and thanks for carrying out further research of my guide, Dr. Nene. So how it will be practicable, because nowadays when people we are telling them the proven methods, don't use black cotton soil, but still they are using that black cotton soil in foundation. So how you will convince
Again,
this is really a very nice technology.
there
Please
is
please
a
go through.
there is a need
Thank
for behavioral change of engineers.
you. Yes, yeah, thank you, sir.
It's not it's not that material is bad. Material is good. You have to handle it carefully. If it is black cotton soil, it is there in your area. You have to treat it or throw it away. And for the ease of economics of the contractor, not of the department, not of the government, not of the person, this behavior of utilizing this non suitable soil for construction of the activity is immediately stopped, and that will be stopped by vigilant people like us,
Right, sir. Right, sir. Yeah.
That will be really helpful.
Yes,
Now
sir. Thank you, sir.
there was a question from flexible pavement, why concrete? I said that title was mismatch. It was wrongly posted on the
Ah,
rigid pavement should be on the flexible pavement and flexible pavement.
yes, 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 that was there.
Yeah.
One thing I want to, it's a very good presentation, and it's a research oriented presentation, because a
Thank
lot
you.
many insight was there in the presentation. You said somewhere some eggs can be make a ground improvement.
Yes, sir.
How these eggs can be
Eggs,
helped to make a ground improvement?
egg shells,
Egg
basically egg
cells.
shells. Egg shells has
Acha,
tremendous calcium.
is say egg cells, not
Eggshells.
eggs.
Not
Not
eggs.
eggs, not eggs.
All
Shells.
Okay,
Cover, cover.
because
Yeah.
no, that
no, it has been shown.
eggs pictures were there, so I thought that how the eggs can be improve the ground.
No, sir.
That was my another is porous asphalt pavement is one of the
Same topic.
emerging technology,
Yeah.
but what can be the alarming or the disadvantages while doing this or practicing this technology, because this is a new upcoming and research in the infancy stage.
Yeah.
So what can be the probable drawbacks or limitations?
Of this,
Mm.
this porous pavements, definitely it should not be constructed throughout the length of your roadway. It should be some particular pocket. It should be constructed because the recharging of the groundwater will be taken place in nearby that area. So that should be
So
first
basically, a focus on recharging the groundwater. Therefore,
ground.
it's not, it should not be throughout, but somewhere maybe
Locations we can
after
identify.
a span of 2 kilometers,
Yeah,
somewhere that can be done.
that will be better approach.
And I think this technology is adopted somewhere in outside India.
Yeah, they are mostly adopted in parking area, not exactly on the road now.
It's a
But now
parking area,
the
basically.
concrete porous concrete pavements, they are now trying for construction of the roads.
Very good.
Yes, sir. One question is there.
Mm.
Can we use bacteria for construction and maintenance of previous road?
Pervious
Previous road,
roads.
see, no,
Previous, nahi, previous,
earlier
previous,
road. No, it may be saying
earlier.
he's maybe saying the bituminous roads which are getting potholes, and then how can we use the treat those? So, see, the bacteria can be used to seal the cracks in concrete. So, if your concrete road is there, definitely this bacteria will be helpful to seal those cracks. Therefore, I said there is a self-healing concrete concept is coming up. That is also a very good research work, a research area rather, where a lot of people are working on that self-heal concrete. So as soon as there is a crack, the bacteria which are present in the concrete, they will start implementing there itself and seal that crack. Now, how it can be implemented to the bitumen at present, I don't know whether it is feasible or not, how much time it will take for that. That has to, again, this research study that is to be done. What
Okay,
is
sir.
the possible ways to validate the result obtained from the lab test to use the same technology in the field? Definitely, you have to first initially any laboratory study has to be taken to the field through model test. In as I talked about these microbials used for improvement of the soil, there is one model study in the sea beach. They had divided some area into 4 different parts, and one was kept virgin, one was kept with some percentage of microbes, other was with some percentage of microbes, and third was some with the percentage of microbes, and they are treated that area, and then they conducted the SPG test on that area, and they found it that the SPG test definitely improved because there is the cementation of the particles taken place. Then that was demonstrated in the field. Now, at present, till now, no actual work has been constructed by using this microbial techniques. Therefore, I say just a beginning. The last 5 to 8 years, these people are working on this area, and they have definitely those who will work in this area. They have 20 years ahead to do further research.
Thank you, sir.
Okay.
Okay. Another question from principal, sir.
Mm.
How specific microbial species can be isolated?
They are available in the market also. There are various labs. At Pune also there is one lab. which sells the different bacteria, and we can
So,
one
such
purchase.
bacteria which can do the calcination precipitation.
Basically, I told Bacillus pasteuria is the bacteria which is mostly widely useful. There are again the people are working on different bacteria also, about 8 to 10 various bacteria they found out, and also my student is working on 4 different bacteria, and we have taken the sample from those labs, from the labs, and then grown in our labs. So we multiply those bacteria in our lab, and then it is utilized.
Okay.
Okay. Uh,
Any more question? No.
uh, yes, any question? I think no.
Now we can conclude.
Okay, sir. So thank you, sir. You have explained
Sir, this was a nice presentation. Thank you, sir.
Who is
Thank
Disha
you.
Balkrishnan? Okay.
Sir Prasad
the sir
Prasad.
done.
from College.
Okay.
It was a nice presentation. Thank you. Thank you very much, sir.
All right. Okay. Thank you.
So, whenever all participants, whenever you are asking the question, we are always saying that you put in chat box. Even if you have to give some good remarks, you can write in a chat box also. Both way it will work. Thank you.
Okay. So thank you, sir. You have explained today about what
Yeah.
is the sustainability according to Brundleton Commission report. Then sustainability in context of pavement. Then how pavement can impact sustainability. How recycled material are used like coarse grain and fine grain recycled material and their applications. Sir also discussed about the ancient ground improvement techniques by sharing some of their research work. How microbial soil improvements, its function and methods is used nowadays is also discussed. How sustainability is achieved by bioengineering for erosion control. I must say, sir, today you have played both the roles of the coordinator as well as the expert successfully. By today's lecture, we came to know that new things that how sustainability can be achieved by using geotechnology for pavement construction. So thank you, sir, for sharing your knowledge and experience with us.
Thank you.
Thank
Thank
you,
you
sir.
very much.
Tekade sir, that attendance link no is not opening. You just check. I tried to
Yes, sir.
open. It's not
Yes,
opening.
sir.
Sir, that's why I put the message.
No, sir, it's working.
No,
I
it is working. No, it is
received
showing.
34 responses till now.
No, but now we are not
Now it
getting.
is not working. I have
Yes,
tried
yes,
twice,
yes.
thrice. है ना?
I
Oh,
also tried. That's why I put that message.
Okay,
Please,
okay, sir.
please,
Okay.
please check. Please check.
उसको ये हो गया होगा.
कुछ तो भी वो एक्सटर्नल साइट के ऊपर जा रहा है और कुछ तो अलग लिख के आ रहा
No, external side is okay, but there also it can be open, no?
Open व्हायला पाहिजे.
Okay, okay, sir. I will check. Okay.
Yes, yes, yes.
Okay.
So it's a break for
15
yeah,
minutes.
a small break and then 12:15 or immediately we have
Yes.
to start.
No, no, sir. 12:15.
So
12:50.
12:10, the Ratnakar Bhasan sir is joining. I have a phone call during my presentation itself.
Okay.
So he's
So
joining
Yes,
at
sir.
better
12:10.
at 12:10 the participants
You
should
should join
join
also. Yeah.
rather than है ना? Again
Yes, sir.
wasting for 5 minutes.
Yeah.
Okay.
Yeah.
चलो
So
थैंक यू
next session will start at
डॉक्टर
12:10.
बढ़िया
Okay, thank you.
Thank you.
Thank you, Dr. Pusatkar.
Thank you, sir. पाठवून द्याल सर. लिंक एक
सर
लिंक म्हटलं चेक करून एकदा पाठवून द्याल, टाकून द्याल आता परत.
हो टाकली आहे मी महाजन सरांना कालच.
नाही 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 ही अटेंडन्स लिंक बद्दल बोलतो.
ओके ओके मी बघतो सर. रेकॉर्डिंग क्लोज करा सर.
रेकॉर्डिंग क्लोज करा. मी करू का? अच्छा ओके.
तुमच्याचकडनं आहेत.